My name is Mike Belov, and I'm a director of engineering at NGINX. And my day-to-day job is to manage development and operations at NGINX Amplify. So, and for this year, the main goal for me and for my team was to launch the general availability release of NGINX Amplify, which we did today. So, congratulations. So, please raise your hand who are familiar with NGINX Amplify. Okay, not many. Okay, so for those of you guys who are not familiar with NGINX Amplify, I have a couple of slides just to tell you about it. So NGINX Amplify is a monitoring and analytical system for NGINX. It collects over 100 metrics for NGINX and for operational system and also for PHP FPM right now. And behind me, you can see the main screen of our system. As you can see, it's pretty clean, pretty understandable. It also has the NGINX configuration parser. So it parses your configuration and it gives you some information about your configuration and shows you warnings and all this stuff. And also it has built-in alert subsystem. And on the last screen, you can see the overview feature. So the one screen with main metrics about overall health state of your application. So and right now you can ask me why I'm listening to this talk. So this is not a product speech. So I'm not talking about NGINX Amplify in this talk. The subject for this talk is how we found ourselves collecting 1 billion metrics per day. And today I just want to share the history of Amplify with you. And it might be interesting for you because it's kind of a nice story of some success, I would say. And it can, how to say it right, you can start to think a little bit different about your development process in your application, or it can influence you to think different about existing tools like Postgres. And Postgres, yes, it's a very old database and it can still surprise you. And the last thing is that it's just a story of, mistakes we made, challenges we faced. So it's kind of cool to learn from mistakes. So just a story, and I'd just like to share it with you. So the story of NGINX Amplify began in 2015. So it was winter in Russia, and my old friend Andrew, he is a professional services engineer at NGINX. He called me and he asked me if I would like to be a part of this new project that we would like to start at NGINX, kind of monitoring system for all NGINXs around the world. And yeah, it was interesting. So I came to NGINX and there was Andrew, the co-founder of the company, and he was mildly crazy about this project. So he was talking and it was very interesting. So I joined the team. We found a brilliant front-end engineer, Ivan. And something like in spring, April 2015, that was our team. So 3.5 persons. So we had product owner, we have a backend engineer, we have front-end engineer, and we have 0.5 operations engineer. So my friend Andrew, he had passion about this project, so he decided to help us when he had his spare time. So what were our milestones, our goals, not milestone, goals? You can read them, just a short list, but as you can see, a lot of things we would like to do. I especially like the last bullet, so think about scaling. What were our milestones? Milestones, again, you can read them. And as you can see, according to our plan, we only had something like 3 months to develop everything. So, and maybe something like a month or less than a month to do performance tests, final polishing, all these things. So kind of crazy deadlines, kind of crazy goals. And when I asked Andrew, dude, this is crazy, we can't do that. And he kind of, yeah, it's crazy, but what's the plan? And I'm, okay, let's think. And basically, we faced the main question of any kind of development. Okay, how can you increase the development speed? And the answer, you can't. So, of course, it's kind of that thing. You can't really start writing more lines of code in a minute. That's obvious. Yes, of course you can, but it's kind of a sport. So you should do something like thousands of hours of development to increase your development speed. And of course, you can do all these things. So hire more engineers, extended work hours, and work on weekends. So I have the special asterisk there. That means that it's not always bad. So if you have established development process and you hire engineers one by one and you spend time with them, so that's fine. That's how you should do things. If you have a new project and you don't have a development process and you hire something like 10 to 20 engineers, well, soon you will find all of them in depression, right? Because how? Extended work hours, well, if you have an outage, it's okay, because you have to fix stuff, right? But if you do it on a regular basis and you guys work on weekends, again, depression and all these things. So this is bad. What you can do instead? Instead, focus on saving time. And for us, it was the only option we had with our crazy deadlines and goals. And we started to think about it. And the first thing we did, we decided to use a very simple architecture. Very simple architecture helps to save some time because it's really easy to understand how it works. So it's really easy to develop things in a team because you don't think about how to install it, how to deploy it, what are the dependencies and all these things. And the architecture of Amplify is pretty simple. So you can see on the left side, we have users that use browsers, web interface, and we have agents that actually send payloads. And users work through a load balancer with frontends. Frontend's pure synchronous thing. Agents work through load balancer with backend, and backend is asynchronous thing. So agent sends payload, we store it locally or not locally, and we process it in a queue. And they all work with database. And that's, so we need load balancers, obviously, for scaling. And this architecture is pretty simple. So it's just like that. The next thing we did is we decided to use tools we already knew. And that saved a lot of time because there are a lot of new things that you wanted to try, and this is a new project, so maybe it's a good idea to try them. Okay, but prepare to spend half of your time trying to understand how things works and reading the documentation and all these things. So we decided to use the things we already knew, so that's why on the front end we have Node.js and React. For API, we use Python because I knew Python at this moment, and UBSG and Flask. And for the backend, for the asynchronous part, we use plain old Celery and RabbitMQ because I knew how they work. For the agent, we use, again, Python and gEvent, just because I knew them at this moment. Okay, we need more tools there, right? And the next step we did to save time, we decided to use tried and true tools. And by tried and true, I mean tools that proved themselves to work. So they are not new, they are not fancy, but you can find documentation. You know their limits. They are tested. They have everything. And you can just start to use them, and you will save time. Because, again, documentation, and people already tried them in any option, in any kind of solution. So you kind of know how they work, and you can rely on them. And that's why, as load balancers, we use NGINX Plus. Well, NGINX. For working with database, we use SQL Alchemy. As a primary database, we use Postgres, plain old database, very good. And we store all the code in GitHub. For the infrastructure, we use SaltStack. And for development pipelines, we use Jenkins. All the old tools, but again, we saved a lot of time because they just work and they have good documentation. But again, tools are tools. What you can do else? Next thing we did, we started to think how we can minimize idle work. And by idle work, I mean the work that doesn't produce real result like piece of code. It's figuring out what to do next. Obvious thing, I think everyone who tried to develop faced the fact that sometimes in the morning you don't know what to do next because your manager didn't think about that and all these things. Next thing is providing the same environment for everyone. Again, obvious thing, all the members of a team should have the same environment, including not only developers, but QA guys, operations guys, and all these guys, they should have the same environment. And it takes time, actually, to provide it. And documenting APIs. Always changing, and you always spend a lot of time to document them. So for the first thing, you can, so the obvious solution is use task tracker. So we use Jira, again, plain old. So somebody hates it, somebody loves it, so we just use it. Pretty good. And the main thing with Jira is that you can plan in advance. So you can use backlog and you can plan in advance for something like a couple of weeks. So for us, the main goal is that when a developer comes to work, he or she should know what he will or she will be doing to a day. So that's the main thing. The same environment for everyone. So we use Docker. We can discuss Docker for production, like for hours, but for local development, it's just perfect. So previously, I could spend in our teams like days just creating the environment that I can use for work. With Docker, it's just 5 minutes, no special scripts that are always break everything and so on. So Docker is the best thing for local development. And for documenting APIs, we use Swagger and Swagger UI. And we don't write the specification files manually. Instead of, we are using special packages for Python, pretty cool, Flask RESTful and Flask REST Plus. And we just write code and we just write some additional doc strings just to specify things, and we are getting the Swagger and Swagger UI automatically. So very easy, and it's so great because you always have documented API. It's always the same, so it just saves a lot of time. What else? Deliver new code frequently. That means that you should deliver your new code something like every day. If you can't do every day, do it every week, but try to do it more frequently, because if you deliver new code frequently, you actually minimize the feedback cycle. So if your backend guys deliver their code today, so frontend guys can start work with that new code also today or tomorrow, and they will provide some feedback like instantly, and you will fix it, or backend guys will fix it, and it just makes the whole process more fast. Instead of, okay, we deliver this something like next week, front-end guys will take a look 2 weeks after, and it just takes a lot of time because obviously it just takes a lot of time. So deliver new code frequently really helps. Next thing is write tests. Kind of very obvious thing, but I saw a lot of examples when people tried to save time not writing tests, and it doesn't work, because if your project is big, at some point of time you will spend all your work time just trying to understand where the bug is. So write tests. At start it doesn't help. After your project becoming more and more bigger, it will help, obviously. Just to wrap up all these things. So 6 things, they're not rocket science, they're just simple things you can find in any kind of book. So we just tried to use all of them. And what was the outcome? The outcome is that in September 2015, we launched the private beta of NGINX Amplify, and it had all the features we planned. And we delivered it on time. And this is the original screenshot of NGINX Amplify in 2015. Of course, it was a proof of concept, so we just tried to implement the thing we wanted. And we didn't know that if people liked it or not, but surprisingly, people liked it. So we started to get more customers, we started to get more data, and we started to get more problems. And the first problem that actually we got was a problem of scaling. So remember that slide that, think about scaling? So we got that problem. And the main problem actually was problem with time series and Postgres. Postgres is great, and it's a very good relational database, but it wasn't originally designed to store time series. And we started to get problems on inserts, on selects, all this kind of things. And so we started to think what we can do. So time series data is just, just to let you know, it's an indexed time series data that looks like that. So time and value. What we did first to kind of trying to tune Postgres, we tried to tune it, and well, it's just one of the examples. Turn off the synchronous commit. There are additional tunings. I will not cover them in this talk because it's kind of an additional talk. But the obvious thing, turn off the synchronous commit. It really helps to improve performance on writes. And it sounds like a bad idea, but it just means that the data will hit your disk not exactly when you push commit, but a little bit later. So that's just it. And if your Postgres server crashes, you will lose that data, but you don't often lose your servers, right? So that's the first thing. The second thing, we partitioned our tables. So Postgres is great with that thing because you can actually partition your table, obvious thing. Instead of one big table, use a lot of small tables. It improved the performance both on writes and reads. But that was not enough. Next thing we did, we decided to think about different schema. And this is our original schema. So it's pretty bad, and you can understand why it's pretty bad, because all the first columns, like count ID, object ID, metric ID, in each row, we had a lot of these things, and they always, all the same, almost all the time. So a lot of duplicated data, huge table, huge indexes, so everything worked pretty bad. So we normalized it a little bit. So we started to use one table for data and one table for metric sources. So just normalization helped a lot because smaller tables, indexes are smaller, everything just starting to work faster. Well, we don't use joins in that case. Okay, that improved the performance for writes. And then we faced a next problem. The next problem is downsampling problem. So what is downsampling? If you have, let's say, 1,000 points, 1,000 data points, but you have only 100 pixels on your screen. So how can you show these 1,000 points in 100 pixels? You have to downsample them. And when you downsample them, you apply some function like average or sum or something like that. And behind me, you can see how AWS does that thing. So it's the same data, but on the left picture, you can see 6 hours of data with granularity step 1 minute, and on the right picture, same 6 hours, same data with step of 5 minutes. So you can see the difference, and you can see how AWS applied average method here. So what is the problem with Postgres and downsampling? Actually, Postgres is really great because it has a lot of functions you can use both for time, for data, for all these things. But the main problem is that it has to process a lot of data. So if we have an agent that sends data, let's say every minute. So for 1 hour, we have 60 data points. Not too many, right? For 4 hours, it's 240. And if you take a look at 7 days, it's more than 10,000. And it's only for one metric. And as I said, Amplify agent collects over 100 of metrics. So it kind of a lot of data, and it really takes a lot for Postgres to process all this data. So it takes a lot of CPU, a lot of memory, and all these things, and you have to solve it somehow. The obvious solution here is that, okay, if Postgres is good with 60 data points, so for all these time ranges, you should have the same amount, right? So let's have 60 data points for the whole week. But that means you have to downsample this data somehow. And there are two options. First option is post-processing. Really easy to implement because you have all this data. You just take this data and process it, right? And just, so let's say we want to have downsample data for a week. We will have a special table for a week, and we will write all these data points to this table. But that means that we actually have to process all this data. We have to do the same job again, but just in background. And that's bad because, again, if you do proper processing, it's not fault tolerant. Because if your script failed, you have to run it again. You have to understand what data points are downsampled, what are not. So it will not work. So we decided to do pre-processing. And this is how we did it. So this is just an example. The left table is the original data. So we collect metrics, we send metrics every minute. We also have two tables for 5 minutes and for 5 minutes and for 10 minutes. And let's see how we work with data. So first metric arrives at 10:04, value 100, and what we are doing with these downsample tables. So since we are talking about 5 minutes interval, we will put this value into a special row in 5-minute tables at 10:05. For 10 minutes, we will put it at 10:10 because there is a step of 10 minutes. What we are doing next? Next metric arrives, 10:05, value 200. In 5 minutes, we summarize values and increase the counter. The same thing we are doing with 10 minutes. Let's see what happens next. 10:06. For 5 minutes, we will create a new row because it's 10:06, it's more than 10:05, so it's a next 5 minutes step. For 10 minutes, it's the same 10 minutes. So again, summarize and increase. And the final step of the example, 10:07. 300, again, 5 minutes, summarize, increase, 10 minutes, summarize, increase. So what we got here, if you take a look at these 5 minutes and 10 minutes, and just think for a moment, if we had a counter metric, let's say 5xx errors, in 5 minutes and 10 minutes tables, we already have downsample data. So we just can take it and use it. If we are talking about, let's say, gauge metric, like CPU utilization or something like that, you can just take value, divide it to counter, and you will get the average for this time period. And that is very easy for Postgres. And for Postgres, it's very easy to manipulate with data this way because it's just one row. Just go to one row and just write a new value or summarize value or increase the counter. It's very easy for Postgres to do these things. So that helped a lot. And what's the outcome of all these 4 steps? The outcome for Amplify is that right now we are collecting more than 1 billion metrics per day. We serve thousands of monitored hosts. Data retention is 2 weeks, but we can store for longer. So 2 weeks is just a product-driven decision because we have free plan and we should somehow think about data costs and all these things, but we can store for longer. And we use only 2 RDS instances. And as you can see, they are not fancy. I mean, it's just 4 CPU and 30 gigabytes of RAM. I believe your laptops have more memory and CPU than what we are using for storing data. So that's the outcome, and that's Postgres. The main question for us right now, Will we stay with Postgres for longer or not? Well, since Amplify is gaining more popularity and we are getting more data and more customers, we started to think about a specialized solution for time series. But this work in development, and right now we are still on Postgres and still just only 2 databases, and that's it. So I hope my talk was interesting for you guys, and I hope it influenced you to maybe review your development process or maybe just think about it. And I hoped that Postgres, this pretty old tool, can still surprise you guys. So if you have questions or just want to talk about Amplify and stuff, well, here's my contact. Feel free to ask questions, and thanks for coming.